Welcome to second in the series of videos on transformers. In this video, we're going to look into the principles of working of how transformer works. All transformers consist of central iron core. So the iron core looks something like this. So you have the iron core here. Sorry about that. Yep. So you have an iron core. And on both sides you have these windings. So this is a primary, which is always your left is your primary, which is your input, and then you have your output. So the output can be output is on the right side, and we usually call this as the secondary. So this is your the input voltage is given by EP and current will be IP, and here for secondary output you have ES and IS. And the transformers work on an AC input, and when we say the primary current is EP, what we mean is the peak current is EP, or the peak voltage is EP, and the voltage is fluctuating from the positive and the negative, right? One cycle of positive and then negative, and then it keeps alternating, and that's why we call it as a AC current. So as we pass a AC current in the input, what happens is, let's say in the first cycle your current is going in this direction. This results in a flux buildup inside the transformer, and that flux is linked using this iron core. And these coils that you see here, they experience a changing magnetic flux. All these coils experiences a changing magnetic flux. The flux is increasing in this direction, so they generate a flux lines opposing that change. That's your Faraday's law. So they have to somehow oppose that change, and to achieve that change, what happens is they, for the first positive half, to oppose that change, you have an output that is, you have an output which is generated by these coils, the secondary coils. And in the next cycle, you will see that the cycle is the current is in the opposite direction. So this will be in the next cycle, and that will result in a magnetic field in the opposite direction, and the changing flux in that opposite direction results in the secondary coil trying to fight that change, and that will result in a magnetic flux which is in the opposite direction of the previous one, right? So this will oppose this, and that will result in an output which is in the other half. So one thing to note is that for the positive half of the input, you have negative half that opposes the change, and then as you have the other half, then you have the positive for corresponding to negative of the input. So due to this changing magnetic field, you have a changing output, which is the voltage at the output, and the number of turns in the primary is NP, and let the number of turns in the secondary be NS. Then we say the turn ratio is given by NS by NP. So this turn ratio is denoted by N. And in the previous video we saw an example of a step-up transformer where we had N is equal to 12, let's say, right? Now your secondary voltage is always N times the primary voltage. So if your N is greater than 1, we say that your secondary is greater. So we say that your output will be greater, and this we call it as step-up transformers. The current for the secondary would be given by the primary divided by N. So if your N is 12, so example, if N is 12, then your secondary current would be 1/12 of the primary. So you can, the current would decrease, or in this particular case, if you multiply your ES by IS, ES into IS, that will be equal to, you can substitute it, NEP into IP by N, or that's equal to EP/IP. So in other words, this is consistent with the energy produced in the input, or the per second, which is the power of the input, is equal to the power of the output. So this is consistent. So these are the key equations for the transformers. Okay, so now there are two types of transformers. So one is called the step up. So you have the step up transformers. So in a step up transformers, you have your NS to be greater than N primary, as we have seen in this previous example. The other kind of transformers are called the step down. Now in a step down transformer, the transformer looks exactly the same, but your primary coils are more than the secondary. So you have a more number of primary, but your secondary is much lesser. So EP, IP, ES, IS. So in this particular case, your N, which is NS by NP, is less than 1. Let's say in the previous video, we saw a ratio of 1 by 50. Okay, so example, this can be 50. So that means your secondary coil is 1 by 50 times the primary coil, right? Now, what impact this has? This works the same as a step up, except that since your N is less than 1, your secondary is going to be N times E primary, and since your N is less than 1, your E secondary is less than E primary. And your IS is I primary divided by N, and since N is less than 1, your IS will be greater than IP. The secondary current would be greater. Now quickly comparing your step down and step up. So let's look at step up versus step down. In a step up, your N is greater than 1. Here N is less than 1. Here your ES is greater than E primary. Here your ES is less than E primary. Your IS is less than I primary, and your IS is greater than I primary here. Since your primary current is large, you have thick wire for primary, and here you have thick wire because secondary is large. You have thick wire for secondary coil. And finally, what are the uses? So you step up a transformer for let's say from a generating station to reduce transmission loss. And your step down is mostly done by your adapters. Your adapters for laptops, mobile, etc. All of these steps down. The other examples for step up would be high voltage production of X-rays. So you need very high voltage, so you bump up the voltage. And an example for step down transformers would be transformers supplying current to home. So that could be one of your examples. Other than that, let's say electric bells could be another example for step down. So that kind of summarizes the difference between your step up and step down. I hope you enjoyed this video. See you in the next one.